In this video, we are going to report the type of node in the tree. Hello, this is Jagan from Grow with Data. I am posting this video to share my knowledge in SQL with you. If this assists you in your interview preparation anyways, I will be happy. Welcome to the 32nd video of our Advanced SQL 50 interview question series. We have different topics to cover and we are now continuing with the Advanced Select and Join related question. This video will be tagged in Advanced SQL 50 questions playlist and the code we discuss in this video will be uploaded to the GitHub. The link for the GitHub page will be in the video description part. Let's see the data set and you can talk about the question more in detail. So we are given a table called tree. This got an ID and its corresponding parent ID. So ID is the unique identifier. So if you see the numbers, 1 is ID which got a null value. This means it don't have a parent. 2 and 3 got the parent as 1. 4 and 5 got a parent as 2. Let's create the table and see the flow of it. If you see the sample data, like 1, 2, 3, 4, 5, right? So these IDs got the parent ID. So we start with 1. If you see the flow chart, 1 is at the top. That means it don't have a parent, no top node for that. So that is the root of the whole tree. So we call it as 1 equal to the root flag. And 1 connects with 2 and 3, right? As a parent, 1 connects with 2 and 3. So 1 goes with 2 and then goes with 3. And then for 2, it connects with 4 and 5. So if you see 2, it got 4, it got 5. So after the root, we can check which are the leaf. That leaf means it is the end of the tree. So after 4, there is no downstream. There is no child node for it. 4, 5 and 3 are nodes which don't have a child node or the downstream node. So those are called as leaf. The inner is one which got a parent as well as a downstream, which is a child node. So 2 is the only node which got the parent as 1 and the child node as 4 and 5. So those kind of nodes are called as inner join or inner node. So we had root which don't have a parent, and we got leaf which don't have a child, and then the inner which is not a root or not a leaf. It has parent as well as it has child. So it called a inner node. So we are asked to find out of all the IDs or the nodes which are root nodes, which are leaf nodes, and which are inner nodes. So those are the 3 things they are asking us to find. We created the table. Now let's see how to do that. First thing, we create a table to find what are all the parent nodes. Select PID from tree, group by PID, and you say count star. We run this. For 1, we got 2. For 2, we got 2, and null we got 1. So I say having count star greater than 1. We do this. I got 1 and 2 as the parent ID. So 1 got 2 nodes, 2 got 2 nodes, right? So these are the 2 things, and I can say where PID is not null, right? So I will ignore the parent part. So I say 1 got 2 nodes, 2 got 2 nodes, greater than 0. So at least 1 node, right? So this is a SQL which gives me all the nodes which are not the parent node as well as they got some child node. So I keep this as a CT table with inner user as. So the CT table we are going to work later. Okay, we are going to fine tune it. For now, we can just keep this as a reference. I am going to join the tree table with this left join inner user I dot, so PID as ID, we can keep this simple, ID equal to T dot ID. So what this will do, it will get the tree table, the 5 IDs, and then check from the CT table which is having child, at least one child node, right? We just combined with that. So the ID combined, like 1, go and check if it exists in this. 2, it has to go check if the parent, sorry, if the ID exists as a parent or not. 3, 4, and 5, we do the same thing. So what I have to do, I have to say T dot ID, and then I have to say case when the PID is null. Okay? If it's null, then it's a root node. Same way, if the ID, right, if the 1, 2, 3, 4, 5, if the ID exists in the CT table, right, that means it got any child node. So I don't want that. When I dot ID is null, that means if there is no record in the CT table, the ID doesn't exist in the CT table, then we call it as leaf. Else we say inner, right? So inner is, it's not, should not be a root, it should not be a leaf, which are all exist in the inner user. End as type of node. So if I run this, I got 1 as the root node because it got null, the 3, 4, 5 as the leaf node because 3, 4, 5 doesn't exist in the PID. So the remaining is 2, which got a parent ID as well as 2 child IDs, which got the inner. So that's what we got here. This is the expected output. This is good, not much a complaint, but the CT table we just did very basic part. So if I bring it here, I should have worked on the CT table much clear. So I don't need the count star because that's not asked for. I just want to get the PID which is not null, that means which is not the root, and I don't have to go with the count star. So I just can get the group by. So at least if it present in the PID, that means there is a node, right? There is an ID. So I don't have to go with all the conditions greater than or all that. So 1 and 2. So instead of group by, I can simply say distinct. Even that helps, 1 and 2, right? So instead of doing the count star and all the extra things which is not required, we simply say find the distinct of the parent ID where the parent ID is not null. That means those IDs which is not null have at least one node, one child node. Now I can use this as a CT table and do the same process again. So this way the CT table is more meaningful, right? We are not doing any redundant work or unwanted filters. So if I run this, I get the same, 1 as a root, 3, 4, 5 as a leaf, and 2 as the inner node. So we get that. Instead of CT table, can we change that to something else? Make the code a bit easier. So we create a CT table and then we connect to the same table again, right? So instead of that, I'm going to have only the CT table, the tree table, and the CTE I am just bringing it here. The ID is null. Instead of that, I'll say the T dot ID not in the CT table part, right? So those IDs should not be in the PID list. Then it's a inner node, right? So you can simply say from, so I can save some space. Then it's inner node, else this. So okay, it's also showing us inner. So t.id, we have put some additional condition. ID not in. Select distinct PID where PID is not. Okay, this we say leaf. I put as inner. My mistake. So 3, 4, 5 is becomes leaf, and 2 as usual got upper parent ID as well as child, so it's inner, and then 1 is root. So first, when you summarize, you see you haven't focused much on the CTE table. We just create the PID and then use that as a CTE table with a tree, and then we did the condition. Then we realized we should have fine-tuned the CTE table. So we fine-tuned it to a simple select statement. And then instead of using a CTE table, we just did a subquery table, so which makes the query much easier and simple. Okay. So I prefer this for the interview point of it, but the second option is also a reasonably valid approach. If you want to practice this code, then this code will be in the GitHub page and the link will be in the video description. This video will be the advanced SQL, and in the description part you will have the GitHub link which takes you to the code base. Yeah, here, right? So here, if you see this create statement, everything which is related to the question 30, we are talking about the question 31 or 32. So that video will have this create statement, what is expected, the first approach where we used a normal CTE table, then we fine-tuned that to a simple CTE table, then we used a subquery table. So all these three approaches here, you can use this for your practice. If you want to join the WhatsApp channel, there's a link here. You can use this and join Grow with Data WhatsApp channel. I will be posting the short videos before the long videos has been posted to the YouTube. So you can watch that before this video comes to the YouTube channel, right? So you can try the WhatsApp channel if you want to see those. Hope you like this video, and thanks for watching.